Hello everyone and welcome to the Get Me class. Today we are going to take a look into the next chapter, and that is the structure of atoms. So in the structure of atoms, we shall start up with the Dalton's atomic theory. So the Dalton's atomic theory becomes the one of the most important theory in order to build our basics. So as we start with the Dalton's atomic theory, the first forward point that we need to understand is that Dalton put forward this particular theory in order to explain the composition of a matter. So therefore, in order to explain the composition of matter, Dalton has put forward the Dalton's atomic theory. Now, in this particular theory, you would see that there are certain important points which he explained during those particular days. According to him, every single matter is been made up of the smallest particle, which he coined them as the atoms. So therefore, the first point is that every matter is made up of the smallest particle, which he calls them as atom. Right? The second point, what he says is about these particular atoms, is that these atoms take part in the chemical reactions. Furthermore, he says that the atoms of different elements are different. They differ from each other with respect to the properties, with respect to the masses. So therefore, he says that the atoms of different elements, differ from each other. Differ from each other with respect to the properties and the mass, right? While at the same time, if you see that two atoms of the same elements, they are identical. So therefore, the atoms of same element, according to him, they are identical. Right? So this was the third point as what he has put forward. The next point what he puts forward is that he says the atoms, according to him, the atoms are indivisible. That means we cannot divide these particular atoms any further, according to him. So furthermore, he says that these particular atoms, what we have, these atoms combine in order to form the compounds. So therefore, the atoms combine, that is the atoms of different elements, what they do is they are going to combine. Okay, when they combine, they will give us the compounds. Okay, so therefore, in order to form compounds. Now, furthermore, what he says is that these particular masses, the masses of the compounds, are equal to the masses of the combining atoms. So therefore, what he says is the masses, he speaks about the masses. So masses of compounds, okay, that is combining elements. Combining elements are equal. They are quite equal to the masses of combining atoms. Right? Now, final thing, what he says is that the atoms, as what we have, these atoms can neither be created nor be destroyed. Right? So these are the few points put forward by Dalton's theory. So let's take a look in all of these one by one. So the concepts put forward by John Dalton regarding the composition of the matter is known as the Dalton's atomic theory. Its important points are, the first point, every matter is composed of the very minute particles, and these are called as atoms, which take part in the chemical reactions. The atoms cannot be further subdivided. The atoms of different elements differ from each other with respect to the properties and masses. So this is the most important point what he put forward during those days. So they are going to differ from each other with respect to the properties and the masses, while the atoms of the same elements are identical in all the respects. So the next point that we have is the atoms of different elements combined in order to form the compounds. The masses of the compounds represents the masses of the combining atoms. Finally, the atoms can neither be created nor be destroyed. Correct. So as we move further, there were certain concepts of the Dalton's atomic theory which could not be explained, and hence there was a next concept which was been rolled out. Okay, and that particular concept is called as the modern atomic theory. Now, this particular modern atomic theory is sustained by certain evidences. The evidences such as the existence of isotopes, isobars, right? So, and the radioactive disintegration type of concepts. So the next concept as what we have here is the radioactive disintegration. Okay, so therefore, in order to support the Dalton's atomic theory, the next concept that came further is the modern atomic theory. So according to the modern atomic theory, okay, so according to the modern atomic theory, there are certain important points which it came further. So according to it, an atom is made up of three fundamental particles. So the three fundamental particles, are, as usual, the protons, neutrons, and the electrons. Right? So therefore, the second point says that is not only these three are the fundamental particles, rather than these three, there are few more important particles that came into existence or which are existing, such as the positrons, the mesons, the neutrinos, or you can call it as a neutrinos, and finally the antiprotons. Well, speaking about the discoveries which were being made, there was a scientist by the name as Soddy. What Soddy did was he discovered the existence of isotopes. Okay, so according to him, The isotopes are nothing more than the atoms. And these particular atoms have the same atomic number, but different atomic masses. So if we speak about the isotopes, for example, the first one, as what we have is, for example, we'll take over here protonium. Okay, so protium with atomic mass as 1. We'll take over here is deuterium with atomic mass as 2. We'll take over here tritium with the atomic mass as 3. Okay, so here, all of these 3 are nothing more than what we have is these are the isotopes of hydrogen. Of course, all of these have the same atomic number, but they have different atomic masses. Well, on the case of the isobars, we have the second one, which is the isobars. So isobars are those particular elements which have the same atomic masses. So here, the different atoms are there, the atoms having same atomic masses. But what it differs is but different atomic numbers. So let's observe this particular case. So here, if we take into consideration of argon, so when we have argon, atomic number is 18. So atomic number changes. Argon, mass number is 14. Okay, on the other hand, if we take a look into the calcium, again, atomic number 20, mass is 40 again. So therefore, in all of these cases, what is happening in the isobars is that these have the different atomic number, but they have the same atomic masses. So such kind of things, we call them as the isobars. Correct. Now, coming forward with the last ones. What they say is these particular atoms combine, in order to give us the molecules. So that was the last one, the formation of molecules. So let's take a look at all of these points one by one. So according to the modern concepts, many concepts of the Dalton's atomic theory could not be explained. And therefore, the foundation of the modern atomic theory was laid down. The modern atomic theory or the modern theory is sustained by the existence of the isotopes, radioactive disintegrations, etc. The important point of the modern atomic theories are as follows. An atom is mainly composed of the 3 fundamental particles, as what we have already discussed. Those are, the first one is the electron, proton, and the neutron. Second one, apart from these particular fundamental particles, there are the other particles which are also been discovered. Which are they? If we observe carefully, those are going to be the positron, the mesons, neutrions, and antiprotons. The third one is about the discovery which was been made by Soddy. So Soddy discovered the existence of the isotopes, and isotopes are those particular elements which have, if you observe, it has the same atomic number, but the different atomic masses. For example, as what we have taken over here, protium, deuterium, and tritium. These are the atoms of hydrogens having the masses as 1 for the protium, 2 for deuterium, and 3 for the tritium respectively. Right? So the second one, as what we have, is the isobars. So the isobars are those particular elements which have the same atomic masses but different atomic numbers. In short, these are the different elements which have the same atomic masses. For example, as what we have was an argon and the calcium over here. So lastly, as he says, that the atoms of elements combine. They combine in order to form molecules, right? So this was all about the modern concept. Thank you for watching. Do take care.